Throughout human history, agriculture has evolved from simple hand tools to mechanized farming. Today, we stand at the threshold of another revolutionary transformation. Agriculture is becoming a high-tech, data-driven industry addressing humanity's most pressing challenges. With global population approaching 10 billion by 2050, we must produce 70% more food while facing unprecedented challenges: climate change, water scarcity, diminishing arable land, and the need to reduce agriculture's environmental footprint. This documentary explores cutting-edge innovations reshaping agriculture for the 21st century and beyond. Technological revolution in agriculture. The farm of the future bears little resemblance to traditional agriculture. Today's cutting-edge farms are high-tech operations where data and precision guide every decision, transforming farming from an art based on experience into a science guided by precise measurements. Precision agriculture. At the heart of this transformation is precision agriculture, using digital techniques to monitor and optimize agricultural production. Rather than applying the same amount of fertilizers across an entire field, farmers can vary inputs based on the specific needs of different areas within a field. GPS and satellite technology enable positioning with centimeter-level precision, allowing for extremely accurate field mapping and equipment guidance. Auto-steering systems guide tractors with minimal operator input, reducing overlap, saving fuel, and enabling precise operations even during low-visibility conditions. Drones and advanced monitoring. Agricultural drones equipped with multispectral and thermal cameras can survey large areas quickly, identifying issues invisible to the naked eye. These aerial scouts detect early signs of pest infestations, disease outbreaks, or nutrient deficiencies, allowing farmers to address problems before they spread. The imagery collected helps create detailed maps of crop health, soil variation, and yield potential across fields. AI and robotics. Artificial intelligence analyzes vast amounts of information, from weather patterns and soil conditions to market trends, generating actionable insights. AI-powered systems predict optimal planting times, forecast disease outbreaks, and recommend specific interventions for different parts of a field. Robotics and automation are reducing the need for manual labor. Autonomous tractors prepare fields, plant seeds, and harvest crops with minimal human intervention. Specialized robots perform delicate tasks like fruit picking and weed removal with precision that rivals human workers, addressing labor shortages while working around the clock. Sustainable farming practices. As we push the boundaries of agricultural technology, sustainability has emerged as a critical counterbalance to pure productivity. The future of farming isn't just about producing more, it's about producing better, with less environmental impact. Vertical farming and urban agriculture. In densely populated urban areas where land is scarce, farms are moving upward rather than outward. Vertical farms stack growing areas in layers, often in controlled indoor environments where light, temperature, and nutrients are precisely managed. These systems can produce up to 100 times more food per square meter than conventional farming while using up to 95% less water and no pesticides. Urban agriculture transforms cities from food consumers to food producers. Rooftop gardens, community plots, and repurposed warehouses become productive growing spaces that reduce food miles and connect urban dwellers with their food sources. Vertical farms can transform underutilized urban spaces into productive agricultural centers. Regenerative agriculture. Regenerative agriculture represents a fundamental shift in farming philosophy. Rather than viewing soil as merely a growing medium, regenerative practices treat soil as a living ecosystem that must be nurtured and protected. Methods include minimal tillage, cover cropping, crop rotation, and integrated livestock management. By enhancing soil health, regenerative agriculture increases carbon sequestration, improves water retention, and reduces the need for synthetic inputs. Farmers practicing these methods report not only environmental benefits but also improved profitability through reduced input costs and premium prices for sustainably grown products. Water conservation innovations. Water conservation innovations are critical as climate change threatens water security. Precision irrigation systems deliver water directly to plant roots, reducing evaporation and runoff. Drought-resistant farming techniques like dry farming and deposit irrigation are being refined and expanded. Some innovative farms implement water recycling systems that capture, treat, and reuse water multiple times. Biotechnology and crop innovation. The genetic frontier represents perhaps the most profound transformation in agriculture's future. Advances in biotechnology enable scientists to understand and modify crops at the molecular level, creating varieties once thought impossible. CRISPR gene editing. CRISPR-Cas9 technology has revolutionized plant breeding by allowing scientists to edit genes with unprecedented precision. Unlike older genetic modification techniques that inserted foreign DNA into plants, CRISPR makes targeted changes to a plant's existing genetic material. This technology enables researchers to enhance desirable traits or remove problematic ones without introducing genes from other species. Climate-resilient crops. Climate-resilient crop varieties are becoming increasingly important as farmers face more extreme weather patterns. Scientists are developing crops that can withstand drought, flooding, heat stress, and other climate-related challenges. Researchers have identified genes that help rice survive complete submersion for weeks, a trait that could save millions of farmers from losing harvests to increasingly frequent floods. Similarly, drought-tolerant varieties of staple crops maintain productivity with less water. Alternative food production. Lab-grown foods and alternative proteins are expanding our definition of agriculture. Cellular agriculture, growing animal products from cells rather than raising whole animals, is advancing rapidly. Companies are producing lab-grown meat, milk, and other animal products that require significantly fewer resources than conventional livestock farming. Plant-based proteins designed to mimic meat are gaining market share and reducing the environmental footprint of protein production. Social and economic transformation. The future of agriculture isn't just about technological innovation, it's equally about social and economic transformation. As farming practices evolve, so too must the human systems that support them. New business models. New business models are challenging traditional approaches to farm ownership and operation. Subscription farming, where consumers pay upfront for a share of the harvest, provides farmers with stable income and shared risk. Equipment sharing platforms allow smaller farms to access expensive machinery without capital investment. Data marketplaces enable farmers to monetize the information they collect, creating new revenue streams beyond crop and livestock sales. Novel agri-food technologies present strong economic opportunities while creating new value chains. These opportunities extend beyond the farm to create jobs in agricultural technology, processing, distribution, and services. Food security and distribution. Food security and global distribution systems are being reimagined to address inequities. Blockchain technology improves traceability throughout the supply chain, reducing food fraud and waste while enabling consumers to verify the origins of their food. Local food systems are gaining strength, shortening supply chains and building community resilience. Digital platforms connect small-scale producers directly with consumers, eliminating intermediaries and improving farmer incomes. As we look toward 2050, the future of agriculture stands at a fascinating crossroads of tradition and innovation. The vision is one of integration, where high technology and ecological wisdom work in harmony. Autonomous tractors will till fields while soil sensors monitor microbial health. Gene-edited crops will grow alongside heritage varieties preserved for their unique qualities. The challenges ahead are substantial. Climate change threatens to disrupt growing seasons and water availability. Population growth and changing diets will increase demand for food. Economic pressures continue to squeeze small and medium-sized farms. But the convergence of technologies and approaches offers hope that these challenges can be met. perhaps most importantly, this agricultural revolution must be inclusive. The benefits of new technologies and practices must be accessible to farmers of all sizes and in all regions. The knowledge of indigenous and traditional farming communities must be respected and integrated with scientific advances. The goal must be not just to produce more food, but to ensure that everyone has access to nutritious, sustainably produced food. The future of agriculture will be shaped by the choices we make today, as farmers, consumers, researchers, entrepreneurs, and citizens. By embracing both innovation and sustainability, we can create food systems that nourish people and planet for generations to come.